Hello, everyone. I'm Alan Willard, Senior Developer Relations Technical Artist. That's what it says down here. Um, I'm going to be talking about location-based effects. And there'll be a little bit of discussion of depth in there as well as part of it. So one of the things I get asked a lot is, how would I do something like the Diablo style? Your character walks behind a wall and you can still see your character. Purely on kind of an art solution side of things, I came up with a way of doing that. So I'm going to be creating a new project here using the third person template as a base. That way I get my camera controls and things like that. So I've already filled out the name and stuff like that and launching it now. So the first thing we're going to do is we'll run around in it, see what it does, and then we'll start talking about how we're going to modify the materials and the camera itself to make this work. So obviously this is the third person template. I've got mouse control of the camera and WASD control of the character. And the default for this is set up pretty close to the character. So my camera is kind of in tight. The first thing I'm going to do, because I know I'm going to want more distance here, is modify that a bit. So selecting the blueprint for that third person character and hit Control E, which will open up the editor. Now, I don't actually need to change the node structure at all yet. This is purely going to move the camera back. So you can see I have my translation widget here relative to my character. I'm going to move this back a ways, let's say about 700 units total. Compile it. And now when I play, I've got a much further distant camera. I'm still centered on my player, but my camera's further out. So now it's more likely that I'll have objects of varying solidity between my perspective and my character, such as that. So the next thing we need to do is actually create the material. So I'll create a new folder in my content browser. Call it materials, and we're going to create a new material and call it m_location opacity. So the important things that we need for location-based opacity is, one, obviously the location that we're interested in, and the other is the surface that we're looking through, because we want to make that transparent or translucent or masked. So the first thing we're going to do is add a quick 3 vector. This will substitute for our location just at the moment, and then we're going to get the world position. So this is a point in space, and this is the pixel that we're interested in doing. So we'll do a sphere mask using these two values. So what this is going to do by default is give me a point in space and a radius around it. So if I set the radius to be something small like 64, you'll see I have a dot in the middle of space. And this is actually anything that overlaps that radius around the point here, 0, 0, 0, will be shaded in some way, either positively or negative based on its proximity and the radius of the sphere mask. If we drop the hardness of that down to say 50, we'll get a softer dot. And again, this is a 3-dimensional sphere that's just being represented on a plane. So we would normally just feed this directly into an opacity or something like that and use that for a nice soft dot for particles. But now we're going to actually update this based on the movement of the player in the world. So the first thing we're going to do is create a material parameter collection. And what this is it's a place where blueprints, other materials can interact. We can store material properties inside of this parameter collection. We'll call it location collection. And inside of this, I can have scalar or vector parameters. So the first one I'm going to do is a vector parameter called location. I'll save that. And now, back in my material, I'm going to grab a parameter from my collection. So my location collection is here. And then it automatically updates and says, well, I have a vector parameter there called location. I'm going to use that. Now, an important thing to note is this is by default a 4-vector float, which means it's got 4 floating point values in what equate to RGBA or WXYZ, however you want to refer to it. We're only ever really going to be using RGB, so we're going to pull off a component mask and set it to be RGB. And then we're going to feed that right back into the same place here on the sphere mask. So we're getting the exact same results here because this, as of right now, has no value set. If I go into my collection and change one of these values, let's say set red to be 32, coming back here, you'll notice my dot is now offset along the x vector because that's what those values represent are some point in the world at that coordinate, and then the material does its work based off of that. So now, if I were to just apply this material to any kind of surface, and we'll go ahead and move this to 0, 0, 0. As I move it, you'll actually see that dot appear and fade on the side of the box because it's all being done in world space. So wherever that vector parameter here in my location collection is set, you can see as I modify this value, it updating here and gives me a relative value as well. I can even move it up or down. So this is giving me some point in space that I'll be updating later with the player's coordinates to drive what will be opaque and what will be translucent. Let's go ahead and set that up really quick. So back in our player, we'll open up his blueprint again. So now we have a bunch of different events that are already occurring based on movement. So we can kind of piggyback of any of those and set a vector parameter. And instead of doing this based off of an existing material, we're going to do it off of that collection. So now I can get the actor location. And since this is the player, anywhere the player moves, that's going to update this value. So now I have my parameter is being updated by my actor location. So my collection is now storing the current location of the player anytime this set vector parameter gets updated. So we're going to do this based off of a few different types of input. So essentially anytime I'm trying to move the player, it's going to update this parameter. I could do this more simply by just dragging off tick, but I'm just going to do it based off of my existing inputs. It'll be just as quick. There. So now, if I take my material and apply it to a few more objects, we'll find some meshes to drop in here. Here we go. So we've got that mesh here. It has my material applied, and it's always black because the location by default starts close to where that other cube was. But we can select these and turn off their collision so the player can run through them. No collision. So now when I play, as I get near them, you can see around me there's a small sphere of essentially illumination at this point. It's just highlighting the objects based on my distance from them. So this is the start of what we're going to use to do more opacity-based things. Right now, my coordinates are three-dimensional. I'm looking at X, Y, and Z, seeing whether or not that point is relevant to the surface that I'm interested in, and shading it based on their proximity. If I wanted to, though, I could just do X and Y. So what we're going to do is we're going to transform these vectors from world to view. And what that will do is it will take the three-dimensional point in space and project it into my camera's coordinate set. I'm going to do that to both the world position of the surface as well as my 3D location. And then I'm going to mask these into just red and green. And this will give me an XY only coordinate set. So now I still have the same result, but you can see the projection has changed a bit. And now we're going to take these cubes and make them a bit bigger. That's a little too big. There we go. So we'll move these around a bit. So what we're doing is we're starting to set up our field of objects that are going to be hidden when the player moves around. To do this as well, you can see the projection is already starting to peek through in certain orientations. Now when I play, you can see anywhere that I'm looking straight through at the player, I'm starting to get that opacity value that I'm eventually going to use for masking. But one thing you'll also notice is the projection is completely through the world. So things on the other side of the player, which I may want to appear to be opaque because it's not trying to reveal me, are still being set with my fall off. So the first things first, we're going to set this up so that it masks out correctly. And right now I'm dealing with an opaque material. I'm going to make it a little closer to the existing material in the level, which is pretty much just a half intensity gray approximately. And then we're going to feed this after we invert it into my opacity mask. And I'm going to set the material to render that way. So you can already start to see where this is going. We're going to add a scalar parameter here called radius, because we're more likely going to want to set this based on the needs of the scene. And we'll set the hardness back to completely sharp edged. So now when I play and run around, there's a very large subtractive circle around me that's being projected through pretty much everything you see on the scene that has my material applied. So let's go ahead and reduce this radius a bit because that was a little much. And we're going to start looking at how to do kind of a one-bit mask. If the result is closer to my camera than the player, then I want to mask it out. If it's further away than the player, I want to keep it. So one thing we can do is we can get the camera position in the world, and we're going to get the distance from my point in space in the camera, basically my player's position in the camera. And we're going to do the same thing with the surface and the camera. And this is one of those things that the order of operation is actually important. We'll probably get it right or wrong. I wish I got it right by accident most often. So what I'm doing is I've got the two distances, the one from my camera to the nearest surface between me and the player, and my camera and the player. And what I want to do is opt in to my masking behavior if my camera, or if the surface is between the player and I. And from what we can see, it looks like anything white will do what we want. So we're going to use this as a lerp. We'll feed this into that. Let's see if I've got this right. Nope, I've got it exactly backwards. Easy enough to fix. So now I'll feed my gray value back into the base color. And unplay. You can see opaque objects don't become translucent until I run into them. Now this isn't perfect. There's math that's kind of a really rough approximation if I get corner onto something, because it is doing a world projection from the camera perspective. There's inaccuracies that cause that slicing effect, but that's only really going to be apparent if your object is right up against where the player's running through. If it's something more like Diablo style, where you only have the top halves of objects transparent when the player runs by, that would work very well. You could have only things above a certain altitude arranged like that, which would be very easy to do in this as well, because you are dealing with world position. If I were to say, look to see if an object pixel location was above a certain Z height, I could say anything below this altitude will stay opaque, and anything above this altitude that is also between the camera and the player will fade out. Now, this isn't restricted to just doing a 1-bit mask like this. The reason I'm doing it with masking is masked objects, their opaque surfaces, receive full lighting and shadows just like the other objects in the world, so you're not going to have any odd shading values that are causing your lighting to look wrong or anything like that. We also have the ability to use our temporal anti-aliasing to kind of fake translucency. So if I do dithered temporal anti-aliasing, this is taking my opacity value and mixing it in with very small noise samples and jittering those around every frame. And what that ends up doing, see if I've got this right, I haven't used it in a little while. Basically, it relies on the way our temporal anti-aliasing works to blur out opaque bits. If you think of it in terms of having a layer of sand, and as you shift those grains of sand around, their kind of opacity representation gets averaged over an amount of time. So we can do, say, half this. Wrong value. I want to go the other way. So I'm actually going to build it this way. There we go. So now we should have a fuzzed out area wherever the player is causing the surface to fade out. Now again, because this is using kind of a historical representation of opacity, it's looking at the last so many frames and averaging the results, this will cause some artifacts that you'll notice, like as I move, it's a little smeary, and then when I stop, it becomes crisp again. Basically, that's because the last few frames as I move contain data that show me being in a number of different places. And when I stop, the number of frames that have me standing in one location increases, so my average result becomes a little more stable. But this could be really useful, especially if you have a lot of high frequency noise in the materials applied to the surface. You end up with that high frequency noise kind of breaking up some of the artifacts that you would see with just solid colors like these. So a lot of the shape to this is very kind of procedurally round. You could easily use textures data as well. So if I wanted to say, let's turn on some of the engine content, and I will grab some noise. So these are screen-aligned UVs. That means that this, when previewed, will be applied over the screen evenly. So if I get rid of this temporal anti-aliasing and modulate my sphere mask a bit, I can start getting that noise look instead, and then play around with the values here. And then feed this in. So now I suddenly have more of a smoky-esque texture. Again, it's still masking, so it's still going to be 1 bit, but this gives you at least something that's got a little more visual interest. And if you use something that's world projected, because essentially what you're doing is rendering those surfaces in a slightly different way, you could use noise instead. Just make sure you don't use the more expensive styles of noise. So noise needs a position input, so we'll do world position here, and a filter width of 1 should be fine. And then in the scale, we're going to set it to be 0.05. That should give us something roughly looks the same, except this is projected in world space. So it'll be true 3-dimensional noise. We'll feed this in the same place our texture was going in. And now when we play, and our shader's finished compiling, you can see it's more in world space projected on the surface, and there's no real visible tiling. So now if you had something where you're looking through foliage and you wanted to see the character through the trees but not see him too clearly, you could set up something like this and it would work pretty well. Now, most of what I've just shown is tailored to work with the player and making sure you can see him. You could easily do this based off of kind of third-party objects. If you had an effect where, say you had foliage on the ground that wasn't visible, and then something happened, some kind of grass explosion, and you had an expanding wave that revealed that, you could set that up pretty easily as well. Where right here I'm setting the location, and I'm updating that every movement input from the player. I could easily set that as being updated from an external source, like a blueprint that I dropped in the world. Or I could even do it based off of just an object's position. Right now, it's being done in the character. If I get rid of that behavior, again, that's pretty easy because I can just delete that one node. And if I were to say, have a ball in my scene, of course there's no sphere, let's find it here. Spelling is very important, and I'm failing at it. All right, so we've got a sphere here. We'll set it to be 0.5. And let's say in our level blueprint, there we go. In our level blueprint, we're going to ontick, just to make it quick. We're going to get the location of the arcade editor sphere. And we're going to set vector parameter off of that same location collection. Again, basically the exact same thing we were doing with the player, but this is off of a third object. Now, back in my location opacity, I no longer want to do this in world space, so I'll just skip over these world to view coordinates and just feed it directly in. And we'll up the radius a bit so we see it more frequently. So now, wherever this object is when the game starts, I will get that opacity back. Let me get rid of the projection stuff because this is no longer necessary. There. Now it doesn't show it during the editor because the gameplay is not being updated. But now wherever I place this sphere in the world, I should get some level of transparency around it. And of course, if I give this physics behavior you can now see as it comes to rest or moves around, it will affect the world around it. Not that I'm very good at steering, but so this gives you an idea how you could have some kind of field effect around an object, and then as that object moves through your scene, it reveals or hides things. You could even have multiple layers of it, so you have as it begins to get close, the surface begins to glow, and then eventually you get that kind of Terminator-esque, burned away, sliced appearance. There's nothing in here that's recreating new geometry on the inside, so being aware that everything is going to look paper thin as you slice through it, it can be a very useful effect in some ways, but obviously used incorrectly, it can break the immersion a bit, so it's something to be careful with. So let's see what kind of questions we've got here. We had a few questions about how to do something like this with being able to render the character through. Doing this works very well for single camera, single player perspective. You would have to essentially manually account for every player that you wanted to render a hole through the world with, which is not particularly difficult if you have a fixed number of players or a fixed maximum. You would have a branching behavior that said, in my collection, I'm going to have, say, up to 4 separate locations. Each one of those locations is permanently bound to a given player. Each player then updates their particular location, and then the shader would then look at it and go, I'm going to sum up the results of all 4 players. If a player's location is 000, I'll ignore it so that you end up with the correct results. But that's a little more complicated than I'm going to set up here, especially considering I only have 1 player. How costly is this, masking out the circle? By itself, it's not terribly expensive, especially when masking, because the expensive part is only the translucency. If I go into view mode, shader complexity, so green is good, red is bad, but you can see it's only red, or it's only more expensive, where it actually becomes transparent. So the completely opaque parts of the object are still significantly cheaper than the translucent parts. So keeping that in mind, not making your the radius of your reveal too large can have a lot of positive advantages. How can we get our camera character has the effect of vibration when the character walks or runs. So that would be something where you could take the get the velocity of your player and add random offset or location to your camera. Would probably be the kind of entry level way that I'd look at doing that. There are other ways of doing it, such as having an actual skeletal animation that plays on your camera to get the kind of roadie run look from Gears, where your camera is basically running a looping animation during certain types of movement. How would you implement Fortnite's impact object wobble, more specifically the material map? Fortnite does a lot of that in the vertex shader by basically pre-calculating how they want the object to move and encoding that. And then they've written a material function for implementing that basically looks to see, have I been hit? Here's the input structure for passing data in so that I know how much to wobble, how long to wobble for, things like that. Could this be modified to support a dynamic number of characters? I touched on that a bit in that it would be a little bit time consuming but fairly straightforward to expand it to a fixed size, and then having a little bit of logic in to discard if your max player count isn't reached. And basically, there's no player 5, so just opt out of calculating player 5. But in terms of dynamic number of characters, there's not really an easy way to do that in this manner. You'd want to have some engineering support, most likely, to do that. If I use a particle system to create a rain effect and I apply a translucent material, why can't I use collision depth in my GPU sprite particle system? That's because translucent materials do not write to the depth buffer. For a number of reasons, it would make it extremely expensive to do translucency if it were in the depth buffer. So it's not something we feasibly do. And that's why you can't use the collision depth effect with GPU particles. Can I place 2 spheres? I can, though, like I said, I would have to extend this a bit. So add a second sphere mask, go into my location collection, and add the second one. Basically do the exact same thing twice. Just like this, and then add them together. And I'll clamp them just to be safe. And then inside of my third person, or my example maps level blueprint, I will add my second sphere. And then do the exact same thing. Only with location 2. So now I'm just doing the same thing in parallel. And now both spheres should work. And if I push this sphere over near the other, you'll see it doesn't double up the amount of translucency because I clamped them, but it would give you the right result. If I did it instead, if I just add them and feed them in, it's likely that my opacity would change slightly when they're near each other, but not significantly. How hard would it be to blend between two materials as a player approaches? That would be really easy. You do the same thing, but again, instead of doing it in view space, you wouldn't do the transform. You'd basically look to see, is the player near this surface the same way I did there, and then lerp between two materials or two sets of nodes inside of a single material. You wouldn't be able to do it directly between two explicit materials, though you could do it as the blend between two material layers. So if you did a multi-layer material and used your sphere mask result as the lerp between those two layers, you could do it that way. Does it have the same performance in opaque material and the opaque part of a masked material? Generally speaking, not quite, because the masked material has a few extra shader instructions that are compiled in. It's fairly negligible. The cost comes from the translucent bits of the shader, and that's primarily in fill rate. So again, you want to minimize the amount of open translucent masked surface on any given triangle. A good way of thinking is something like a tree leaf. If you have a large quad with a little leaf taking up part of it, the majority of the quad being transparent would be expensive. But if you contour your triangles to the leaf shape a little bit better, you'll get the performance benefit of the opaque part of the leaf with the translucent border, but without a lot of overdraw because you're contouring it tightly to the leaf shape. Is there a way to tell the object to go fully transparent if it is affected by the transparency effect rather than masking out specific pixels? You could, in theory, instead of doing per pixel, you could do it based on the object itself. You could do that just as easily in Blueprints, though, by, perhaps not as easily, but you could do that in Blueprint by doing a trace from the camera to your player, and if it hits something, then either set the material on that object to be translucent or hide the object completely, something like that. But again, that would be the entire object simultaneously rather than any kind of progressive effect. How would you go about filling the inside of an object with pure black using materials so that the object peeks through so if the camera peeks through the object, you get a kind of cross-section effect? Unfortunately, short of filling the object with triangles that are all kind of inward facing, I don't know of an easy way to do that. If you wanted to have like an approximate solid result, like you were actually slicing away the surface, that's where you start to get into things like ray tracing and ray marching through a volume, which is not something I'm going to even attempt. Is there a way to store the player's visited location to apply a visited material, such as a fog of war of sorts? Not through the material system, though. If you use Blueprints, you could store kind of a grid of information of, has the player been in this part of the world, and if so, set a flag that then is expressed in the material. Looking through kind of a list of opacities of whether or not you render a portion of a material in a given location based on whether or not the player has been there. So there's workarounds for that, but there's nothing. We don't provide a way to accumulate data into a texture, which is kind of what you'd need. You'd want to essentially be painting. during gameplay. So you as your player moves, you're storing his location in a mask texture and updating that mask, if not every frame, then frequently, so that the end result is a mask you could use for Fog of War. Somebody wants to know how to make a toon shader. There's a number of different ways. I'm not actually going to get too far into that here, but most of the ways that I've done it involve doing some kind of outline around the character and then dramatically playing around with the lighting on the inside of the shader, basically looking at it as I'm going to fake a light direction, usually using the location or the collection parameters. So you have a vector that is your lighting vector. I'll show you approximately what I would do here. Light vector. And then in your shader, I'm going to get rid of some of this. And there. So I'm going to tell it I want from the location collection the light vector. I'm going to set the light vector to be 1 along X, just so I can see something. And then I could do a dot product of this and my vertex normal. Again, 4 vector float versus 3. I need to mask it for RGB again. There. So now you'll notice that the highlight is on the X side. That's because essentially what I'm doing is I'm feeding in a direction for my light. So I would start with this as a way to begin approximating writing your own lighting path inside of a normal shader. If you're at all experienced with HLSL and C++ rendering or programming, you could probably write a much more efficient shader model yourself and invoke it in the engine. That's not something that I can nor will be doing, but as a kind of an artist approximation or workaround, that's the kind of thing that I personally would do. Would be start with something like this where you're just doing a dot product and then you start to massage that data into what you want. How hard would it be to make the translucent effect blend between subsurface geometry at multiple points, basically damage for a starship or a very large vehicle? If you wanted to have, let's say, progressive layers where you have an outer hull, then an inner superstructure, then a substructure, then interior, you're basically looking at each of those as a separate step where you need to do a couple different things. One, obviously, each material has to invoke that behavior. You have to have, the outer hull has to have the masking behavior, the inner hull, and so on and so forth. That's not terribly difficult. You then have to basically store the results for each layer. So if you want to progressively blast your ship, I want to blast away the hull and then the superstructure, substructure, and so on, you'd have to essentially store, have I been hit here before or not? If I have, pass that data down to the next layer, which could be, depending on how complex your scheme is, could be very easy or difficult. Alternatively, you could have it be in a single shader and then accumulate in a way in that your instance would have a floating value that said how much damage has been done, and then you're progressively adding to that, and that increases the amount that the effect is being applied. So there's some ways of doing it that without spending the hours necessary to actually build out a prototype of it. I can't say for sure what kind of stumbling blocks you might run into, but it should be possible to do something like that. Using the object position for full object opacity is often not convenient, depending on the object pivot and its size. It is possible to get the precision of pixel position, but still apply the effect to the entire object. In combination with blueprints, possibly, in that you could opt in to see whether or not the object got hit at all and then check for pixel position, or you could do it with a threshold where if you're basically, right now my masking value for these objects was the default of 0.33 repeating. If you decrease that clip value so that it's much more likely for it to become translucent and increase the radius, you could make it so that it was extremely sensitive and tripped over very quickly. But that wouldn't necessarily give you the same amount of precision. My suggestion would be to play around with looking at the in blueprints, comparing positions to find out whether or not you care about an object, and then driving the object's opacity with a blueprint instead. I think that would be a more flexible and iterative way of looking at it. So I'm going to wrap it up at that. Thank you very much for your time and attention. I hope somebody found it educational and at times entertaining. I'm sure I'll be doing another one of these again at some point in the future. And again, thank you very much for watching.